So let's begin. We're talking about the horizontal component of an applied force. So, after this, you'll be able to calculate the horizontal component of an applied force and use it in F equals ma. So let's just look at this picture here. Now I need to not get ahead of myself like I did in the morning. What we have here is we have a FA applied force, and it's being applied at some angle, right? And that, could be like most of the ones we've done up to now, actually all of them, not most. The horizontal force, the applied force has been horizontal. Right? Horizontal. With the exception of the ones where it's sort of like that drone bird's eye view top down kind of thing, right? So now we're going to take that applied force, and because we're tall, we're going to apply it at some angle. Okay? And what you introduce there is what we call the horizontal component. Okay? Now, in past years, I've called the horizontal component FH, force horizontal. And then I realized last year that kids were getting mixed up here. They thought that the FH was a different force than the FA. And so I'm working towards calling it FAX. And what do you think FAX stands for? Force applied X component. And the X means? Horizontal. I guess you could have FAH, I guess, if you want. But I think X is probably a better. So you will see in all the solutions, you'll still see FH. I may refer to FH. I'm trying to get myself talking about more FAX because, again, the FAX is the X component, the X part of the applied force. Okay? Now, you're going to see that picture a few more times. Don't keep drawing it. It's just going to be there on the screen for me to work with. Okay? Okay, so in a situation like this, and I'm going to continue to do this as well. I'm going to leave that FH there just so that you've seen it, but I'm going to keep doing this throughout. Just keep changing it to FAX. In a situation like this, not all of the applied force goes into accelerating the object horizontally. Some of that force not only is sideways, but some of it is actually up and down. What would you call that? It would be the vertical force, or the vertical component, we would say. And what would you label that? FAY. Right? It would be the Y part of the applied force. Right? Now, let me just see here what's coming up next, so I don't want to get ahead of myself here, right? Okay. Only the horizontal component acts horizontally and contributes to the acceleration. So the FAY does nothing to how fast it moves, right? FAY does nothing to deal with how fast it goes sideways. Okay? This is a good lead-in as well to grade 12 unit in projectiles because we break everything into X and Y components. Momentum as well. That idea of components is a process or concept that's expanded on in grade 12. So this is your first sort of look at components. And the value of FH, or the value of FAX, the horizontal component, the X component, is dependent on the applied force and the angle. Okay, so when I say the value of FH is dependent upon the applied force and the angle, I think I've spelled dependent on wrong there, right? That should be not depended on, it should be dependent, right? Yeah, it should be dependent. What I mean there is this. If that is my applied force, if the angle is less, right? Oh, that's not the way I want to do it. If the angle is less, so let's go back to this one here, because this one worked before. If the angle is less, right, then this applied force, that horizontal component actually gets longer, right? If it gets really, really steep, then that horizontal component is only to there, right? And in fact, more of it is actually vertical. In fact, if that angle is perfectly straight up and down, well, then it's all vertical and no horizontal at all. Okay? And of course, if it's longer, well, then it's greater too, right? Will the, maybe I'll hold off on that question. I'll hold off on it. Okay, so there's that picture again. Now, suppose here's an example of finding the applied force. So suppose that the FA, the applied force, is 100 newtons and the angle is 30 degrees above horizontal. That means this angle here is 30 degrees. When I say above horizontal, horizontal just means a flat line, and we're going to go 30 degrees up from there. Okay, so now we're going to use good old grade 9 trigonometry.
Oh,
You probably thought back then, oh, when am I ever going to use this?
I'd love to.
Yeah, it was the good old days, right? When things were easy.
Yeah, you didn't have to study.
Is that right?
Yeah,
Ah, the good old days.
you didn't have to study. You just pull the calculator out.
Suppose FA is 100 and the angle is 30 degrees above the horizontal. So how do we find F? Oh, I got FH again, don't I? FAX. How do I find it? Oh, there's my picture again. You're not going to redraw it, are you?
No.
Which of the three, sine, cos, or tan, am I going to use? Well, I've got the hypotenuse, and this one is the adjacent. So which one has adjacent and hypotenuse in it? Cos. Cosine is adjacent over hypotenuse, and I think, yeah, I'm going to write that up here for you. Cosine theta is adjacent over hypotenuse, right? A over h, that's right. Okay, so it's going to be cosine 30 is equal to, which one is adjacent? Braden, you're not watching? Which one is the adjacent? The FAX over the hypotenuse, which is 100. So we're going to write that, right? Cosine 30 is equal to FAX over 100. Grade 9 trig. How do you solve that? How do you get FAX all by itself? It's attached by a divide by 100. So what do? Multiply by 100 to cancel. Multiply by 100. So you're going to get FAX or FH is equal to 100 times cosine 30, which is 86.6. So the question I had before was, is the FAX, is the horizontal component always going to be less than that applied force? Will the FAX always be less than, guys, I'm teaching here. Here's where you learn something. I'm showing you how to do it. Will the FAX always be less than the applied force? Absolutely, right? The hypotenuse is going to be the longest one, right? And if the angle is relatively small, like 30 or less, then it's not going to be a whole lot less. Like 86 is pretty close to 100, right? If it gets really steep, right? If it's going to get really steep like that, right? Well, then it's going to be even smaller, right? And you'll find out when you get to grade 12 or grade 11. You guys have unit circle yet? Not?
I don't know.
Okay, when you get to unit circle, that'll make a little more sense to you. All right. So, yes, Josh? I take 100 times the cosine of 30. Are you in radians or degrees? Now, if that angle increases to, say, 60, and this is kind of what I was talking about, well, then it's just going to be cos 60 equals FH over 100. You're going to get 50, right? As the angle gets bigger, the horizontal component actually gets smaller. Now, I don't think I'm going to do that here.
Why not?
No, I'm thinking about something else. Okay? And that works for any angle, right? It's the same process over and over and over. Really, all you need to write here is if the angle gets bigger, the FH gets smaller. That's all you really got to know. As the angle gets steeper, the horizontal component gets smaller. Good check, yeah. Makes sense? November 30th. Here's example number 1. So what you're going to find is we're going to do 3 problems, and they're...
Someone was actually screaming at me saying that it was on this page while I was writing down.
You showed them, didn't you? All right. Okay, so here we go. What you're going to find is we're going to do 3 problems. They're going to get increasingly more difficult. Okay, I'm just going to keep adding steps. So stay with me. Here's how we do it. We have a force of 100 newtons applied at an angle of 30 degrees above the horizontal to a 25 kilogram sled. Determine the acceleration if the surface is frictionless. Here's our free body diagram. We have 100 newtons at an angle of 30 degrees. It weighs 25. Right? And we have a weight force down, and we have a normal force up. But the weight force and the normal force, do they contribute? Do they do anything? Do they change anything?
No, they're equal.
They're equal. They're balanced. The net force is 0. You would even say the net y component, the net y is 0. Right? So in fact, most of the time, we don't even bother putting them on there because they don't matter. I'm not really too concerned about them. Okay, so determine the acceleration. We're going to get the acceleration from, don't write this down just yet, we're going to work backwards. We're going to get F net is equal to MA. And what is the net force horizontally? What's the only force that's horizontal? Well, that's the FAX, the X component of the applied force, right? So that is our net force, so we have to find FAX first. We got to find FAX first. Now, pause. Pens down. Watch me for a second. Pencils down. Pencils down. You might write cosine 30 is equal to adjacent FAX over 100, right? Is it always going to be cosine?
No. Why not?
Cosine is always adjacent hypotenuse. Will we always have a hypotenuse?
No.
That's the applied force, right? So we're always going to have that hypotenuse. The question really is, will the FAX, will the X component of the applied force, will it always be adjacent?
No.
You're just reading my body language. That's all you're doing.
Yes.
Will the FAX always be adjacent? If the angle's on the other side, is that what you're saying, Kaylee? Kaylee's saying this. Kaylee's saying that if the angle is like there, then it's actually, and she's right, then it's opposite and it's sine. But 99, Braden, you're not listening to me, 99% of the time, the force is going to be applied at an angle above the horizontal. Very rarely will it be stated, this would be not from the horizontal, this would be 30 degrees right of vertical. It happens very rarely. So, what I'm saying is, 99% of the time, it's going to be cos.
Not 1%.
And is it always going to be then, is FAX always going to equal FA times the cosine of the angle? 99% of the time, yes. 99% of the time, the horizontal component is going to be the applied force multiplied by the cosine of the angle. So if you want to start with that, you can go ahead. Some people like that. If you want to start with that, you go ahead. But realize that I'm not saying always. If it's vertical, it's out the window. Then it's simply okay. So we're going to write, really what we're doing here is we're doing this. You don't have to write this down. Really what we're doing is FAX over FA. I'm really multiplying both sides by FA. Does that work? Can you do that? Can you multiply by a variable? Why not? But you can multiply by its value.
But it doesn't have a value.
But you can still multiply by the value FA. It doesn't matter what it is. When you multiply by FA, the FA's cancel. You guys have seen that. Canceling, and then you get the FA over there, right? So all you're doing is you're doing the manipulation before you do the numbers. Okay, so as I was saying, what you're doing is you're manipulating before you put the numbers in. I don't recommend that, but eventually you're going to have to be able to do that. Okay, so anyways, let's complete this question. So I've got, I'm going to write now, next step, I'm going to write FAX is equal to 100 cos 30, which we already know to be 86.6, I think, right? Didn't we just do that? And now I got to get FAX equal to my FNet. Well, it's the only one, right? It's the only one. Can we just say FNet is equal to FAX? Not all the time, but in this case we can because it's the only one, right? If I said this, add up the number of calculators on that desk. Well, there's one, right? There's only one thing to add. You're not adding anything. You're saying one. Then we're going to take that, and the 86.6 goes in for my FNet. And here we've got a mass of 25 times the acceleration. How do I solve that? Divide by 25. Now I need that calculator. 3.5? 3.46? We'll say 3.46 meters per second squared. Really, that's just a two-step problem. You could argue with me that it's a three-step if you want. You might win. I don't usually get too excited about those. Is that what you mean? It's not a bad idea to do it. Okay. What would be different? What can I do to make this sort of one step harder? I guess friction. So what's going to happen when there is friction? What step is going to be different, ladies? What step's going to be the last step? Or this one? Determining the FNet, right? That's going to, because there's not going to be one calculator anymore. There's going to be two forces, right? Let's try one like that. So here I have a force of 50 newtons. It's applied at an angle of 15 degrees. So there's my 50 newtons. There's my 15 degrees. The sled has a mass of 30, and the friction force is 5. Oh, I put 15. Okay. One more step. It's just I have to take care of friction. The friction force is 5. And we'll talk about it whether it's negative or not right away. Usually, okay, well, I'll talk about it now. Usually you don't put it on the free body diagram that it's negative. That I've seen. Although I guess, well, I mean, is it going to hurt? Probably not. It just means that it's going the other way, that's all, right? Yeah. And the question doesn't even say left or right, really, does it? But we tend to assume that it's going to the right, and that way the friction's negative. Okay, so first step, solve for the horizontal component. FAX is equal to FA cos theta. or 50 times cosine 15. I get 48.3. Okay, so of that 50 newtons, 48.3 goes sideways. FA cos theta. Whoa. What did you say? This would help in math? Oh. Yeah. Having grade 11 math certainly helps. Yeah. It's not necessary because there's nothing that we do that you haven't done in math already, but it helps. Okay, next step. Now the next step before was to write what our F net is, but this time we've got two forces. So the net force is going to be my FAX plus my friction force. Keeping in mind that that friction force, 48.3, is negative 5. So my net force now is 43.3. F net is equal to FAX. What's the friction force? No, it's plus. I'm adding the forces together, but it's negative 5. It's to the left. Where? I was just talking about whether it should be negative or not, right? I don't think it matters. I mean, as long as you do it right here, right? I don't normally put it here, right? I'm saying I don't care if it's here or not. As long as you do it right over here. No, I mean, the fact that it's pointing left tells me that it's negative to begin. Don't get hung up on that. And now, what's the next part? F net equals MA. Again, notice I'm putting my steps in little chunks. I'm lining up my equal signs. I'm writing the formulas, even though I know how to do this. 43.3 is equal to the mass of 30 times A. How do I solve? Divide by 30. 1.44 meters per second squared. Josh, did I hear your voice? No? Oh, yeah. Well, then you better go. Here's example number 3. I've added a couple more steps. Let's read it together. A man is pulling his 50 kilogram son, he's big, on a 15 kilogram sled across an ice surface with a friction force of 2 newtons. The rope makes a 30-degree angle with the horizontal. He applies a 250 newton force on the rope for 3 seconds. Find the final velocity and the distance it travels in 3 seconds. So this last little bit sounds an awful lot like the kinematic stuff from the last unit. Physics is like Shrek and parfaits. Lots of layers. And onions, yeah. Parfaits are more fun. Okay. So, hang in there, you guys. I need about 5 more minutes. Do we add the mass of the kid in the sled? I'm just added. That's just one extra mark that I'm able to give you. Don't blow that kind of thing. The mass is 65. Do I need to show the work for that, do you think?
No.
Nah, that's pretty, that's...
Can if you want.
Can if you want. We have 250 newtons of applied force, and we have friction force of 2. So we're going to do exactly the same steps that are going to get us to the acceleration, and then once we have the acceleration, then we can do final velocity and all that stuff, right? Review from last unit. Well, we'll get to that, right? So I'm going to write FAX, the horizontal component, is equal... Oh, the angle, thanks. Yeah, 30 degrees. FAX is equal to FA cos theta. So that's 250 times cosine 30 216.5. Everybody with me so far? Do you see the steps that are coming?
Yes. Wait, is that a 216?
216. The net force is going to be the applied force plus the friction force. So that 216.5, and we're going to add a -2. Hopefully you don't need a calculator for that. Please tell me you don't. There's a few things we assume you can do. Subtract 2 is in that category. Now we're going to go F net is equal to MA. 214.5 is equal to the mass. Now here's where you got to be careful. It's 65, right? Divide both sides by 65. And I get 3.3. Oh yeah. So that's basically what we did in example number 2. Now, to find the final velocity. It doesn't come right out and say it, but generally when big kids sit on sleds, they start at 0 at rest. So I think we can reasonably assume, especially because it's not given, that the initial velocity is 0. And so A equals delta V over delta T. 3.3 is equal to delta V over time 3 seconds, and you get a change in velocity of 9.9, right? Multiply both sides by 3. If the VI is 0, what does that tell us? Right? That means that the VF is also 9.9, right? If you start at 0 and you change by 9.9, well, then you're at 9.9, right? Okay. To find the distance it travels, the distance formula is V bar equals D over T. Do I have V bar?
No.
I don't. V bar is average. I have VF. So it's V bar equals VI plus VF all over 2. Oh, yes, you are, Caleb. It takes practice. It takes practice. It's like knowing what to do when you're driving. Oh, but you will. You will eventually. It takes practice, knowing what to do. There's how many when you're driving a vehicle, how many possible situations can come up? Well, thousands. And the only way to know what to do is to practice.
You just wing it.
You know, it'd be so much easier if you could work there. We need to finish it.
Yeah, I agree.
That'd be the way to go. Yeah.
You know, it would be real easy too if someone would tie my shoes for me, make my dinners for me, mark all my tests for me. That'd be awesome. Oh yeah. Earn my money for me so I don't have to work. So we're going to take 9.9 and we're going to divide it by 2. And we get 4.95 is our average velocity. Yeah, I knew you were going to ask that. Well, let me finish the question first of all.
Honestly, if I see a question like A, I'm just going to do every single.
Just think through. It's all logic. It's like, what's the next step? So V bar is 4.95. We're solving for displacement. The time is 3 seconds, right? No. No, I expect you to.
It doesn't matter what you think yourself.
Okay, so 14.85 meters is our final answer. Now, we have to answer the question, how much is it worth? So let's go 1, 2, and 3, 4, 5, 6, maybe 7 if I want.
Do you really want that? Well, I guess it helps.
I think it would be, I think you'd need it here in this case,
But
right?
like in this case, if you don't get the first answer right, the rest of them are.
I guarantee you, if you make a mistake here with that 216.5, if I see all this work and all laid out perfectly,
Good market.
I'm not even going to follow the math. I'm just going to give you 5.5 out of 6.
Just because we.
Well, I can see you know what you're doing.
You're answering it wrong, but
Yeah,
what you do is
yeah.
right. Okay.
Absolutely. If you go 250 divide by cos 30 here and get some stupid number, I'd probably take a half off and follow everything through. Not probably. I would. I probably wouldn't even bother with the math.
You just do half wrong. And you do the rest of it.
Okay. Jaden, put the phone away. All right. So I'm going to be quiet right away. You now have the ability to do on the first set of the first problem set that I passed out on Thursday. Questions 7 and 8 are marked horizontal. You can now do those. When you flip the sheet over, question number 2 is the same. So there's only 3 problems that are all like that. Just listen for a second. Just listen. Just listen. Don't back up. Just listen, because I know what happens. I do all this, and then people say, so what do we do? Listen now. I'm telling you. Put your backpacks down. Put your binders down. Listen. 30 seconds. Okay, so on the front side of that sheet, questions 7 and 8 are marked horizontal. On the back side, number 2 is marked horizontal. If you didn't, I'm going to come around. Some of you that have been here in the last 2 days did get this. I'm going to hand this out as well. I've been told these problems are more challenging, but there's no horizontal on it. Okay, so I'm going to hand these out as well. You've got lots of practice questions. Use this time right now. Don't pack up and say, oh, he's done. Here's where you learn how to do it by practicing. That's what good students do.
You know what I'm gonna do tonight? I'm gonna watch this. I'm gonna train my own little